This video may be a bit of a change of pace from the content that I'm usually making, but I thought I'd share it on here because, for one, there is actually a surprising amount of LEGO involved in this project, and it's just taken me a lot of time, so I thought maybe some people would be interested in it. We'll be getting back to Technic a bit later, though. Got some other videos, or some other projects I'm working on. So this here is my 3D printer, and the project here was to make a multicolor unit for it that would allow me to print in 4 different colors, but to do it on a tight budget using LEGO electronics to add to the 3D printer ones. So from here I'm going to cut to a video that I filmed a few weeks ago that showed this project in an earlier state, and then I'll come back to the present at the end to show the changes I've made since then. So this is a project I've been working on for quite a while now. It's an attempt to modify my standard Ender 3 to have 4-color or multi-material capability. And the idea was to do it using a LEGO Mindstorms and basically just stuff I had lying around to keep costs extremely low. So it's currently all there, but it's not working reliably. So I'm not sure where I'm going to go from here, but I thought I would make a video at this point of progress to show how things are working. So, where should we start? So the basic concept for the color change is that normally you'd need extra stepper motors to be controlled to do the other colors. That requires another motherboard, which is very expensive. So the idea was if I could offload that computing to something like this LEGO Mindstorms here, I could be able to do that using only things I had on hand. So then the issue was, how do I actually get the printer to communicate with the Mindstorms to know how to do it? Maybe there's some way that I could, like, I don't know, take a USB from the Pi, I'm using Clipper on it, over to the Mindstorms and translate the files, but I'm more of a hardware guy than a software guy, so I thought maybe I can just do it a hardware way. So the idea was, I now have this LEGO Mindstorms touch sensor set up here. So we can move the bed all the way forward, and then a printed part in there just bumps the sensor. Oh, I have this in a bad spot right now. Apparently it's hitting my camera. My webcam. So that's here, bumping the sensor. And then the other part, so it does that first to tell the Mindstorms that we're doing a color change. And then for the second part, it needs to know what color we're changing it to. So to communicate a more discrete position, I mounted this down here with 4 separate colors on different pads on top of a Mindstorms color sensor. So it parks in one of these 4 positions, placing one of 4 different colors on top of the sensor, which then tells the Mindstorms motor how much it needs to rotate. So then we move up to this here. This was originally designed to be placed on top of the frame, but for other reasons it ended up getting really noisy, so by hanging it here I was able to isolate the noise. But anyways, the way this works, we've got our normal Creality stepper motor, and it is driving this specialized LEGO part in here, which just says 5.5 to 1 planetary gear reduction, because it didn't have enough torque in direct drive. Then that drives this here Mastercraft screwdriver, which, I mean, I could have cut off the handle here, but it was just a 5mm shaft I had lying around that I didn't really need, and that was the right size. So then that shaft has extruder drive gears there, and there, and there. So that is running filament down these 4 paths. So like a normal extruder, we've got a spring-loaded mechanism to push the idler wheel against the gear. So like this here, just like a normal extruder. So currently, this brown filament here is the one that's selected. But in order to change that, we've got our Mindstorms motor up here, running a worm screw onto a worm gear to drive this shaft here. It's using an Allen key for the shaft because it was metal and could index stuff. Then we have these 4 semicircular cams, and those rotate here to, basically it's pressing these 3 in to disengage them, and this one here is the only one that is not currently engaged. So on the motor side, this is what a filament change would look like. So now the second one is selected. Third is selected. Fourth is selected. And back to first. Another important feature is the filament cutter to prevent drawing melted filament back in and clogging things up. So it works basically the same way that it does in like a Bamboo Labs printer or anything like that. It just goes out to the end of travel here, presses against that, and cuts the filament. So for the cutter, I just have a piece of a razor blade from a knife that I glued in there. Snapped off very dangerously and made it the right size. Then we've also got a purge chute down here. So just a little bit of silicone to wipe the nozzle. And then I lined the chute with aluminum foil tape just to keep it from sticking. Alright, now we're going to home it, and then I'm going to run the filament change G-codes, and we're going to see what we can show you. Like I said, things are not as reliable as they should be, so I'm not sure how much of it will actually work, but hopefully you can get the idea. Alright, so home. Alright, so this is the end filament, or end of the first extruder is what's happening. So it went to the edge to try cutting, then because of reliability it's trying again. The motor stalls, so it has to come back here to reset itself. And now we've got retraction happening up here. Alright, I'm now going to run the extruder 2 start G-code. So we've bumped this sensor to tell it we're starting, then we've moved to the correct color. Now the Mindstorms motor is spinning, moving the cam to the right position. And now we've just got a decent number of seconds to wait, because there's actually no way for the Mindstorms to communicate back to the printer to tell it, yeah, we've changed filament successfully. So instead of that, I just have a delay programmed in, just to make sure it's had time to get everything done. Also, I think it could probably be fine-tuned to be shorter in this instance, but in some cases, if it's going from one to the other, it could be a longer time. Anyways, we're extruding now, as you can see by the screwdriver moving. Let's see if we actually get filament out. Then we get a little wipe action. Yeah, it's not extruding right now. It's probably jammed up in here somewhere, which is one of the problems I'm going through with this. And then it does a final little wipe, and homes again, and then it would be continuing the print. So yeah, now to talk about the issues I've had and am having here. So for one, the filament cutter isn't very reliable. I think it often works, but it really needs to always work. I've thought about a solution where I could just take some cutters like this, install them above the extruder here, have open space, and then just have this move into position when it needs a cut, then have another Mindstorms motor actually move them to cut it. But that sounds like it'd be a lot of work, for one, kind of janky, and I think it would make another problem I'm having worse. So, right in that crack there, you probably can't see that great. Flashlight. There's, I don't know, just a crack under that Lego shock absorber part, and that is where the cutter action happens. And because of that, there has to be a gap in the PTFE tubing that's used to feed the filament through everywhere else. And because of that gap, sometimes when you're feeding a new filament in, it will miss the place where it needs to go in after the cut and jam up. So that's a pretty major problem, and I'm not sure what to do about it. And yeah, I'm pretty sure making a larger gap to fit in cutters like this would only make that problem worse. Another problem I'm having is that my wipe over here is not working as well as it should. There's usually still residue on it that goes back to the print. And I haven't done any really long prints, but stuff doesn't always fall down the chute, so if you had enough purge cycles, it might build up and cause problems. That one I could probably get around by forgetting about the purge chute and going to just a purge tower. So that's not the most crucial. Another problem we have that isn't that important is because of the high spring tension involved here, my prints keep breaking like that. And then there's just some unreliability in the changing there. But that can probably be worked with. So really what I'm stumped on is how to get a more reliable cutter in there, and how to get a more reliable filament pass going down there. And then, beyond that, just motivation to actually do all the work that would go into it. But, yeah, I'd be happy to know what your thoughts are on this fairly unusual project I've been working on. Alright, back to the present now. So since I made that video, I've made a few changes. The first change I made was I removed the filament cutter. So we've now just got a pretty standard print head. The idea was that by not having the cutter that was unreliable, I would be able to just always retract the same amount and just hope that the tip formed properly. And that kind of worked. I got some prints out of it, like this Alaska license plate here. Pretty simple model, you definitely don't need a multicolor unit for that. But I did start having problems with jams, which is kind of why you would have a cutter. I tried making a fairly complex multicolor print with this Settlers of Catan hex here. But we had some issues. We had some layers jam right down here. Or, yeah, there was a jam there that I fixed about a layer afterwards. And then it jammed up pretty bad again here. And it was just messy. So, that did not work out quite the way I had wanted it to. Another thing I changed was I reprinted this whole upper assembly in PETG instead of PLA, hoping that it would be stronger. Now I also changed the design and actually removed some material here, so I actually made it weaker in the end. This is kind of a patch I made with some zip ties, but as you can see it's broken here. So it would require printing this again with a stronger body on it. So at this point I'm not really planning on going forward with the project. It was a neat idea, but I feel like I'd need a lot more time and possibly some more money, and even then I don't really think it would do a very good job, and I wouldn't use the functionality much. So I think I'm just going to leave it as an interesting proof of concept, and yeah, probably revert my printer back to a single extruder pretty soon. I've got an adapter here all printed for a direct drive conversion that I'll probably try. So yeah, it's been an interesting project, but I think it's time to just get my printer back to being reliable again.